All right, hello everybody. This is Mrs. Masteller once again, and we are continuing on with this chapter that's all about probability and then also statistics. So we're getting into the more stats portion of the whole entire chapter. And the section, we're finally in chapter 11 after getting out of chapter 0, but chapter 11, section 1, it's titled Designing a Study, and this lesson's pretty wordy more than anything else, so it's actually going through the steps of designing a study, knowing the difference between an experiment, an observational study, a survey, things of that nature. Okay, so let me just kind of walk you through what is a statistic at the top. The definition of a statistic is that it's a measure that describes a characteristic of a sample. And it says these are the steps now. So going straight across, a little flow chart, the steps in a typical statistical study. So the first thing you want to do is identify the objective of the study. So what are we trying to actually study? Next thing, choose a sample and collect some data. So whatever data that may be. Organize the data and then calculate some sample statistics. So doing things like, the mean and the median, the mode, the range, the standard deviation. Those would be our calculations. Then we want to make inferences and draw conclusions about the population. Okay, key things to keep in mind though is you don't want to ever have a bias when you're creating your own study. So what is a bias? It's pretty similar to even when you think about it in an English class, it's an error that results in a misrepresentation. Okay, because you want to choose a random sample when you're doing an observational or just doing a study in general. Okay, so your sample always want it to be random. So what is a random sample? It's a population. It's exactly what it sounds like. A population selected entirely by chance. And for some reason, what kind of pops in my head is I think about this like in relation to a courtroom, right? So if you were going into a courtroom, let's say that you had something coming up, maybe you were on trial for something, you would want the jury to be completely random. Okay, you don't want people walking in that are going to be on the jury that are going to be completely biased or have some type of assumption about the case already. You want them walking in having no information whatsoever prior to the case. You want it to be completely random, like I said. So again, I don't know why that just always pops in my head when I think about situations like this, but that's always a good representation. That's always a good analogy, I would say, is just thinking about like in a courtroom. Okay? So, the key thing in today, though, is knowing the difference between these three. So, what is a survey? What's an experiment? What's an observational study? So, a survey, I think we all know what a survey is. There's kind of a example over there. So, it says to determine whether the student body likes the new cafeteria menu, the student council is going to ask a random sample of students for their opinion. So, it's basically just people giving their opinion on something. Okay, so you can do a survey in many different ways. You can have just kind of different options and have them kind of check off what they think. Um, so again, if we're talking about a cafeteria menu as an example, maybe we can send out a survey asking, would you like to have hamburgers for lunch? Do you want spaghetti for lunch? Do you like salad bar? Things of that nature, and then they can kind of check off their opinion. Okay, but that's an example of a survey, so let's kind of put a definition to this. It's data that's collected from responses given by members of a population regarding their opinions. Okay, so I'm sure we've all even done a survey probably at some point in time in our life. Okay, you can even do it obviously now on social media too. You can send it out on Twitter, you could post a survey on Facebook, things like that, and get people's opinions. Okay, what's an experiment? So this is exactly what you think about when you think of science class, right? You're doing some type of an experiment. If it's going to be an experiment, you have to have two things. You have to have an experimental group. There has to be an experimental group, and there has to be a control group. So hopefully this sounds familiar. Experimental group is obviously the group that's getting the experiment done to them, and then the control group is the one where nothing's being done. Okay, and then you're just comparing the two groups. So you're actually conducting your experiment and then comparing the two groups. So here's an example of an experiment. It says a restaurant's considering creating meals with chicken instead of beef. They randomly give, another typo, they randomly give half of the group of participants meals with chicken, the other half with beef. They ask how they like the meals. Okay, so that would be an example of an experiment. Observational study says over here as an example, researchers at an electronics company observe a group of teenagers using different laptops and note the reactions. Here's kind of the key thing right here, is they're noting their reactions. So it's really just observing how people react to something. Okay, so an observational study is members of a sample are observed without being affected by the study. So it's just completely putting something in front of somebody and just noting their reactions. Okay, you're not trying to manipulate the situation at all. Whereas an experiment, you're going to actually be controlling the differences and the changes and things like that. Okay. So on the next page, we have to, in the directions, we're going to try to determine whether each situation is going to be a survey, an experiment, or an observational study. Then identify the sample and suggest a possible population from which it may have been selected. Okay, so reading through number one, like I said, it's going to be kind of wordy today. So we might have to read through these two more than one time. But it says a record label wants to test 3 designs for an album cover. They randomly select 50 teenagers from local high schools to view the covers while they watch and record their reactions. Again, this little key part at the end here is kind of sticking out to me. This is definitely an observational study. They're observing, they're notating, okay? They're watching and seeing their reactions. That's just an observational study. Okay, as far as the sample goes, so what is our sample? Well, it's going to be the 50 teenagers. That's our sample. And where can this sample be selected from? What's the population then? So where are we taking these 50 teenagers from? It says from local high schools, right? But we probably are selecting from potential purchasers of the album. So students who are actually a fan of this group, right, that would actually really care to be a part of something like this and have some type of say. So again, potential purchasers of the album is probably most likely going to be our population. For number 2, it says the city council wants to start a recycling program. They send out a questionnaire to 200 random citizens asking what items they would recycle. Keyword that's popping out to me here is a questionnaire. If I'm sending out a questionnaire, that's just a survey. I'm surveying these citizens of the city. Okay, so our sample, who are we surveying? 200 random citizens. That's our sample. And then where are we getting these citizens from? Where are they being chosen from? What's the population? Citizens of the city, obviously, right? So not just choosing any 200 random people. We want them to actually be within the city limits because, well, it's going to be affecting them anyways. We're talking about their recycling program. So it's going to be citizens of the city. The next one, number 3, says scientists study the behavior of one group of dogs given a new heartworm treatment, another group of dogs a false treatment or a placebo. So they're actually manipulating the situation, right? So we have two different test groups, if you would. One group of dogs is getting heartworm treatment, the other one is given a placebo. That would be our control group. So this is definitely an experiment. So now we've definitely seen one of each. An experiment, and then what's our sample? Sample would be to the dogs that are given the heartworm medication. And then what's our population? It could really be to any dog, right? To any dogs. I'm assuming it's within a certain area, but it doesn't really say where we're at, if we're in a city or if we're in a town or if we're in, some rural community. So it can really just be to any dogs in general. And then to number 4, it says a retro movie theater wants to determine what genre of movies to play during the next year, and they plan to poll 50 random area residents, and ask them what their favorite movies are. So again, key thing I'm popping out right now is talking about a poll. If I'm polling people, that's a survey. And then let's see, our sample would be the 50 random residents. That's our population. Where are we choosing this where are we choosing this sample from? What population would this be? Probably just people who actually go to the movies, right? I'm not really going to ask anybody per se. Maybe those people who frequent the movies often, they would want to have a say in what genre of movies that they should be playing at the movie theater. So just really all potential moviegoers. Okay. So you guys seen how that kind of works? It says when you're designing a study, it's important to write questions that are clear and precise and that do not introduce any sort of bias that may affect the results of a study. So to prevent that from happening, it says you want to avoid survey questions that are, number 1, they're too confusing or wordy. Okay, so you don't want to be going on and on and on. Just basically get to the point. Don't make anything too confusing, too wordy. Don't cause a strong reaction. If you're encouraging a certain response, so these two kind of go hand in hand with each other. Those are pretty similar statements, causing a strong reaction, encouraging a certain response, addressing more than one issue. So again, you just want to be concise, to the point, okay? You don't want to be too wordy. You don't want to be going on and on about something. Just be straight, direct. Don't be causing any sort of strong reaction or response. So we were trying to determine if these questions, if they're biased or unbiased, and if it is biased, and explain your reasoning. So for number 5, example 5, don't you agree that the cafeteria food is nasty? Okay, so even just reading that, obviously I'm encouraging you to basically agree with me, right? So this is definitely a biased question. So if I had to describe why is this bias? Again, I'm encouraging a certain response out of you. And that's something that you want to avoid. This is encouraging and encourages a certain response. By starting off saying, don't you agree, I'm encouraging you to agree with me. Okay? Next one, how often do you work out? This can be, again, if you can honestly prove it to me that it's biased or unbiased, if you can write a reasoning to kind of back it up, I'll probably be able to see it either way. Because working out to me is honestly anything. Even if you're just walking around the building right now, if you're walking from class to class, to me that's a workout. You're getting steps and you're getting exercise. So to me, this would definitely be unbiased. Okay, some people though connotate working out with actually physically going to a gym, and getting in their fitness and everything else. But to me, working out could be almost anything as long as you're active, as long as you're up and you're moving around, that's working out to me. Number 7, how many glasses of water do you drink in a day? To me, that's unbiased. We're drinking every single day. I mean, every single thing we drink has water in it in some way, shape, or form. So to me, that's definitely unbiased. For the last one, do you prefer watching exciting action movies or boring documentaries? That's obviously a biased question. Definitely biased. And the reason why, well, again, it's saying exciting action movies versus a boring documentary. So having those adjectives kind of thrown in there, I'm definitely encouraging you. I'm encouraging a certain response. So again, just by having those extra adjectives, boring, exciting, I'm encouraging you to answer a certain way. Okay? So now designing a study for our next example, it says that Jim is writing an article for his school newspaper about online courses. He wants to conduct a survey to determine how many students at his school would be interested in taking an online course from home. So state the objective. Well, he's trying to gather and figure out if students have an interest in taking an online course from home. That's his objective. He wants to know their opinions on that, right? Identify the population. So where is he going to choose these students from? Probably his school, right? So basically the student body. Students at a school would be his population. And then write 2 unbiased survey questions. So if he was coming up, with this survey, how can he develop a couple questions that would be completely unbiased? So a couple that I wrote down, number 1, which would probably be a good question to ask, is first of all, do you have internet access at home? That's probably a good thing to ask, especially if they're going to be taking an online class at home. Probably need to know if they have internet access. And another question I developed, if it's offered, would you take an online course? Okay, so again, just very quick, to the point, concise, just getting general information. Maybe you'd even want to ask questions about, what type of courses would you like to have online? Okay, or what type of courses would you like to have access to if you had an online course? I would still constitute that as being an unbiased question. Okay, so our last couple examples, the directions say we're going to identify any flaws in the design of the experiment and describe how they could be corrected. Okay, so we have these experiments, identify again what's wrong with it, and then we'll try and fix it as well. So here's the experiment. An electronics company wants to test whether using a new graphing calculator increases students' test scores. A random sample is taken, another typo, scratch out the word of, a random sample is taken. Calculus students in the experimental group are given the new calculator to use. Algebra 2 students in the control group are asked to use their own calculator. So the results they came up with, so again, keep in mind they're testing out this new calculator, this new graphing calculator. They're trying to see if that increases test scores. Okay, the calculus students were given the new calculator. The algebra 2 students have their own calculator. They don't get the new one. So their results came out with this. When given the same test, so they're still the same exact test, the experimental group scored higher than the control group. The company concludes that the use of this new calculator increases test scores. So what's wrong with this? Well, calculus students are going to obviously score higher than algebra 2 given the same test. So it doesn't really even matter what type of calculator they're using regardless. To me, that's what's wrong with it. Calculus students, just because they have a higher math background, but calculus students will score higher than algebra 2 students given the same test. Okay, so how can we fix this? So there's kind of a couple different ways you can fix this scenario. Here's what I wrote down. So that either test strictly calculus students with and without the new calculator, or strictly test just the algebra 2 students with and without the calculator. So they are basically changing 2 things. Not only are they changing the calculator, they're also kind of changing the sample in which they're testing, right? So you either want to just test calculus students or just test the algebra 2 students with and without the calculator, and then giving them all the same test. Okay, maybe even try both groups, right? Maybe do calculus students, give them all the same tests with and without this calculator, and then same thing with algebra 2. Okay, so just to sum this all up, I said either test strictly calculus students with and without calculator, or test strictly Algebra 2 students with and without the calculator. So that's really the best way to really gauge how this is going to work. Okay? Next experiment, it says that a research company wants to conduct a study to determine whether a new fishing reel is more effective than the old one. The experimental procedure consists of using the new reel to catch fish in one lake and using the old one to catch fish in another nearby lake that is randomly chosen. The company concludes that the new reel is twice as effective as the old reel. What's wrong with this? So if you need to, again, I'll give you a second, kind of read back through. So we're trying to test out a new reel, right? To see, is it more effective? Do I catch more fish with this new reel versus the old one? And they're saying that yes, you do. So the problem that I see, now that you've kind of had a little bit of time to think about it, the problem that I see is that we're using different lakes. We're using the experimental reel in one lake, and then we're using the old one in a different one, in a nearby lake, right? So the issue is we're using them again in different lakes. You know, for all we know, there might be different populations of fish in each of the two lakes. Okay, there might be more fish in one lake than there are in a different one. And most people that fish probably know that. Okay, so how can we fix this? We can use each reel in each lake or both reels in one of the two lakes. Use each reel in each lake if you want it to, or again, you can just simply use both reels in one of the two lakes. So we can use both lakes if we want to, but you want to make sure you use both reels in both lakes, or just use one of the two lakes altogether. Okay? So again, a little different today as far as that goes, but that is our lesson today on designing a study. So again, if you have any questions, as usual, just come and talk to one of us. Thank you and have a great day.